Welcome to the video lecture on Computer System Architecture CS405 based on Kerala Technical University syllabus. First of all, I introduce the topic of the Module 1. It's about parallel computer models. Topics includes evolution of computer architecture, system attributes to performance, Amdahl's law, multiprocessors and multicomputers, multivector and SIMT computers, architectural development tracks, and conditions of parallelism. The session 1 includes the topic evolution of computer architecture. Let's move to the first topic. The study of the computer architecture involves both hardware organization and software requirements. We can define the computer architecture in two ways. First one is the programmer's view. In an assembly language programmer's view, the computer architecture is abstracted by instruction set, addressing modes, registers, and so on. From the side of a hardware, it is organized with CPU, cache, buses, microcode, pipelines, physical memory, and etc. So we can say that the study of the architecture covers both the instruction set and the machine implementation organizations. As we all know, the computer has its own architecture on how computer works. It is concerned with the structure and the behavior of the computer. You have already studied about the types of architectures. There are two types of architectures, von Neumann architecture and Harvard architecture. These are the diagrams of these two architectures. The evolution of the computer architecture model started with von Neumann architecture. It is designed and developed by the Greek scientist John von Neumann in 1945. Most of the today's computers run on this architecture, whether it is mainframe or personal. Let's see the architecture. The components of the von Neumann architecture includes the input device, the central processing unit, memory unit, and output device. And the central processing unit includes CU and ALU. CU means the control unit and ALU means arithmetic logic unit. First of all, the input stores in the memory. The input becomes command and ready to process. The process will fetch the command from the memory unit. As I told earlier, the processor includes two units, control unit and arithmetic logic units. The control unit manages the input and output data. When the input is entered to CU, it passes to ALU for the arithmetic calculation if it is needed. And then the results stored in the memory and display in the output device like monitor. Von Neumann architecture built as a sequential machine and it is executing scalar data. And the sequential computer was improved from bit serials to word parallel operation and from fixed point to floating point operation. But there is a drawback for von Neumann model. It is slow due to the sequential execution of instructions in the program. So we have to move to some advanced technique that are look-ahead technique, parallelism and pipelining, FLYNN'S classification, parallel or vector computer. Let's start with look-ahead technique. It is introduced for enabling the instruction prefetching. We know the processor fetch the instructions from the memory and execute it. But what do you mean by prefetching? It means that speculate on future instruction and data access and fetch them into the cache. The basic idea is when you think about accessing some instruction or data, fetch them in advance and save into some cache memory. Please note that the instruction access is more easier than to predict the data access. As you know, the processor has three steps: fetch, decode and execute. In this look-ahead technique, it is used to overlap IE technique, means instruction fetch and execute technique. And third one is it is also enabled the functional parallelism. That means the different functions are distributed and performed simultaneously by the processor or different processors. In parallel computing, more than one processor run at same time, doing some computations and divide the workload with each other, and thus increase the speed and performance of the system. Look at this pic. Fi means the fetching time of the instruction I, and EI denotes the execution. Without instruction look-ahead technique, the instructions fetching and executing done sequentially, one by one. But in look-ahead technique, after completion of the fetching process of ith instruction, the processor can start the fetching of I plus 1th instruction and the execution of ith instruction at the same time simultaneously. This will definitely reduce the processing time and increase the efficiency. That is the difference between without instruction look ahead and the with instruction look ahead technique. Next topic is FLYNN'S classification. Michael Flynn in 1972 introduced the classification of various computer architectures based on instruction and data streams. These are the four types. First one is SISD, means single instruction stream over single data stream. Example for SISD is the conventional sequential machines. Second one is SIMD, single instruction stream over multiple data stream. The examples for SIMD are vector computers. Third one is MISD, multiple instruction stream over single data stream. Special purpose computers are the examples for MISD. And fourth one is MIMD, multiple instruction stream over multiple data stream. Parallel computers are the example for MIMD. Next topic is pipelining. It is a technique where the multiple instructions are overlapped during execution. Pipeline is divided into different stages and the stages are connected with one another to form a pipe-like structure. That's why we call this technique as pipelining. Instructions enter from one end and exit from another. It will definitely increase the overall throughput of the system. Next one is parallel computers. As I mentioned earlier, as per the Flynn's classification, the parallel computers are the example for MIMD. That means multiple instruction stream over multiple data stream. The execution in the parallel computers are carried out simultaneously. There are two classes for parallel computers. First one is shared memory multiprocessors. Second one is message passing multicomputers. Shared memory multiprocessors uses the common memory and they can communicate using shared variable. In message passing multicomputers, each computer node in the multicomputer system has its own local memory. And the interprocess communication done via the message passing system. So we can analyze that the distinction between the shared memory and multiprocessors and the message passing multicomputers lies in two factors, that are memory sharing and interprocess communication. So I will repeat, in shared memory multiprocessors, it uses the common memory and they can communicate using the shared variable. While in message passing multicomputers, each computer node in the multi-computer system has its own local memory and the interprocess communication done via the message passing system. These are difference between the shared memory multiprocessor and the message passing multicomputers. Next one is the vector computers. It is a processor whose instructions operate on vector data. And the vector computers are the example for SIMD, that means single instruction stream over multiple data stream. There are two families in vector processors. First one is the memory to memory and second one is register to register. In memory to memory, it supports the pipelined flow of vector operands directly from memory to pipelines and then back to the memory itself. But in register to register, it directly uses registers to interface between memory to pipeline. This is the major difference between memory to memory vector computer and the register to register vector computer. Then look at this figure. This figure depicts overall evolution of the computer architecture from sequential scalar computer to vector processors and parallel computers. And so we can see that, as I said earlier, the evolution of the computer architecture model started with von Neumann architecture. Von Neumann architecture built as a sequential machine and it is executing the scalar data. So it has a drawback. It is slow due to the sequential execution of instructions in the program. So we have to move to some advanced techniques. In this, first one is look ahead technique. Look ahead technique, it is introduced for enabling instruction prefetching and it is used to overlap IE technique and it is enabled functional parallelism. And next one is FLYNN'S classification. FLYNN'S classification, there are 4 streams: SIST, SIMD, MIST, MIMD. And then pipelining is a technique where multiple instructions are overlapped during the execution. It will definitely increase the overall throughput of the system. Then next move to the parallel computers. The parallel computers are the example for MIMD system and there are 2 classes: shared memory multiprocessors and the message passing multicomputers. And then the vector computers, it's a processor whose instructions operate on vector data. It's an example for SIMD and we can classify these two families: memory to memory and register to register. And this is all about the evolution of computer architecture. Hope you all can understand about the evolution of the computer architecture. Thank you.